In today's lesson, you will learn to deal with fractions as exponents. You already know how to deal with integral exponents. You know that if you have a positive exponent, it tells the number of times to use a base as a factor. Any base raised to the zero exponent is 1, and that a negative exponent tells you to take the reciprocal of the base. Today, you will learn what to do when you have exponents such as 1/2 and 3/2. Let's start by remembering the square root. The square root of a number is one of two equal factors whose product is the number. Example, the square root of 25 is 5, since 5 times 5 is 25. In other words, to find the square root of 25, I need to find one of two equal factors whose product is 25. Now 5 is equal to 5. They're factors because they're multiplied. And if I multiply 5 times 5, I get 25. So the square root of 25 is one of these two equal factors. So the square root of 25 is 5. But we also know that the square root of 25 is negative 5, since negative 5 times negative 5 is also equal to 25. So actually, 25 has two square roots. The square root of 25 is 5. The square root of 25 is also negative 5. Now I'm going to give you some notation. This symbol is used to denote the positive square root of n. So if you see this symbol, it's used to denote the positive square root of n. This symbol with a negative in front of it denotes the negative square root of n. So this symbol denotes the positive square root of the number. This symbol denotes the negative square root of the number. Let's look at some more examples. The square root of 49. Now since there's no sign here, it's understood to be the positive. So this means we want the positive square root of 49. The positive square root of 49 is 7, since 7 times 7 is 49. The negative square root of 64 is negative 8. This tells me we want the negative root of 64. And the negative root of 64 is negative 8, since negative 8 times negative 8 is 64. So the negative square root of 64 is negative 8. The positive square root of 4/9 is 2/3. The square root of 4 is 2, because 2 times 2 is 4. The square root of 9 is 3, because 3 times 3 is 9. So if I multiply 2/3 times 2/3, I will get 4/9. The square root of 4/9 is 2/3. The square root of negative 4 is not real. Now why isn't it real? Well, the reason is that one cannot take the square root of a negative number within the real number system. So the square root of 4 is not real. One cannot take the square root of a negative number within the real number system. Now why is that? Well, you might say that, let's try 2. Well, if I multiply a positive 2 times a positive 2, I get a positive 4. we might guess that the square root of negative 4 is negative 2. But if I multiply negative 2 times the negative 2, I also get a positive 4. Now if you multiply two numbers that are equal together, they obviously have the same sign. If both of them are positive, the product is positive. If both of them are negative, the product is positive. So there is no way within the real number system to multiply two numbers and get something that is negative. So therefore, one cannot take the square root of a negative number. Now let's generalize the notation from square roots to any number of roots. This symbol, the nth root of x, and notice the n is inside the little v there. So note the n is inside the little v. The nth root of x is used to denote the nth root of x. In other words, the nth root of x is one of n equal factors whose product is x. The nth root of x is one of n equal factors whose product is x. Now if a number has two real nth roots, then the nth root of x denotes the positive root. So if a number has two real nth roots, then the nth root of x denotes the positive root. The opposite of the nth root of x denotes the negative root. Now this last one, again, is important, so I'm going over it. If a number has two real nth roots, then this symbol denotes the positive root and this symbol denotes the negative root. Now that's only when the number has two real nth roots. Now if there's only one real nth root, then this number denotes the only one you have. Let's look at some examples.